Question 44. A quadrilateral has these following properties. First, you should know a quadrilateral is a four-sided plane shape. Examples are square, a kite, a rhombus, a rectangle, and so on. Hope you understand. The first property says opposite sides are parallel and equal. That means when you say opposite sides, for example, these are opposite sides, they are parallel and they are of the same length. Same as these two opposite sides are parallel and they are of the same length. This could likely be a square, it could be a rectangle at this point, but let's just take this as the shape based on the first property. On the second property, it says adjacent sides are perpendicular. This word perpendicular means they are 90 to one another. So what's meant by adjacent side is the two sides or the two lines meet at a point. That makes them adjacent to one another. If you take this side is adjacent to it. This side is also adjacent to it. That means this is 90 and this is 90. This side is also adjacent to this, and this side is also adjacent to this side. So this is also 90 and this is also 90. And it says but they are not equal. That means adjacent sides are not equal. So if this is the longer side, this is the shorter side. That makes them adjacent to one another. So this is a rectangle because this side is not equal to this side in length, but this side is equal to this. That means these two are the same and these two are the same. So this is a rectangle. The last property says all its interior angles are equal. That means this is 90, 90, 90. So this is actually a rectangle. Find the number of lines of symmetry of the quadrilateral described. They could ask you to first name the quadrilateral, but in this case you are not asked. They only asked how many lines of symmetry does the quadrilateral have. A rectangle actually has two. And a line of symmetry is a line that divides a shape into two, of which one is like the object of a mirror and the other is the image, which is the reflection at the line of the mirror. That might sound a bit complex. This is an example. It's a line that divides this rectangle into two. If you fold it in two, the two sides would align. This is one line of symmetry. The second line is right here. If you take the rectangle and fold it at the middle here, you get the two sides aligning on one another. But if you consider this diagonal and fold this rectangle at the line of the diagonal, you see that when you fold the rectangle by this line, you will notice that this side doesn't align or doesn't sit exactly on this other half. So this is therefore not a line of symmetry. Same as this second diagonal too. If you fold the rectangle at the line of the second diagonal, this half doesn't sit exactly on this other half. Therefore, these diagonals are not lines of symmetry. And a rectangle actually has two lines of symmetry. So the answer to question A is two lines of symmetry. You can do an experiment to truly understand this. Note that for a square you have four lines of symmetry because all the sides are equal, and when you fold by the diagonals, the first half sits perfectly or aligns on the second half. That is, if you fold by any of the diagonals apart from folding by the vertical line of symmetry and the horizontal line of symmetry. Question B. Find the rotational symmetry order of the quadrilateral. Some students might not understand what this really means, but the answer to this question is actually two. The rotational symmetry order of a quadrilateral, which is regular, is always the same as the number of lines of symmetry of the quadrilateral. Let's say we have this rectangle here and you rotate it 90. If you rotate it 90, it will turn to this. That we're rotating it clockwise. This is not the same as this. Here is as if the rectangle is lying flat. here it's standing upright. If you rotate it 90 again, you have it like this. Now, this looks exactly like this. We've done 90, 180, next rotation is 270. So we go this way again. Therefore, this will now be standing. This doesn't look like this. If you go the fourth time, you have it like this. And this looks exactly like this. So a rectangle has the rotational symmetry order of 2. We have 1 and 2. If you rotate it 360, you will get this same shape only twice. That's why it's 2. As said earlier, for regular shapes, the number of lines of symmetry is always the same as its rotational symmetry order. Note, if you have a rectangle like this and you have this on it, let's say it's shaded. If you rotate it clockwise 90, you have this. This part will now be here. If you rotate it 90 again, it will lie. That means this place will now be flat on the ground. Then this place will be shaded. Although both of them are flat, but this is not same as this. If you rotate it again 90 degrees clockwise, it will be standing. And here we'll have shaded parts. This is also not the same as this. If you rotate it one more time, 90 to complete 360, that's 4 times. We have it here. We have this same shape as this. Although this shape is from a rectangle, it has the rotational symmetry order of 1. It's only once that you have this same shape when you rotate it 360 degrees. And here is it. You should note its line of symmetry is 0. Because let's say, for example, you take the shape and draw a vertical line at the middle. This is not the same as this. You might fold it and it might lie on it, but this part is shaded and this part is not shaded. That means it's not a mirror effect. And if you also divide it horizontally, this part is not also the same as this. This part is shaded, but this part is not shaded. So it has no line of symmetry if you are given this shape. Hope you understand.